Hello, this is Sergio again, and in a previous video, I had shown you how I came up with an equation which determines which numbers are prime numbers. In this video, I'm going to show you a simple way to manipulate the original equation so that you could come up with a new equation to determine which numbers are twin primes. Actually, you could manipulate the original equation not only to determine which numbers are twin primes, you could manipulate it to determine which number are sexy primes, which number are twin primes, which number are any pair primes of any given distance from each other. For the other equations, it's you have to think a little about the resulting equation is a little bit more complicated, since you have to take into consideration the fact that there might be a prime in between the two primes of the given distance. But determining an equation for twin primes is pretty simple, pretty straightforward. So I'm going to show you how I did it here. And then later on, I might show you the video to come up with the general equation to determine any pair primes number of any given distance. Okay, so let's just start with the simple one, which is coming up with an equation to find out which pair of primes are twin primes. Okay. This was my original equation. I already showed you in a previous video how the equation works and why it tells you which numbers are primes. Basically, you put in for x. If the equation solves, if this equation equals to 2, the number is prime, otherwise it's not prime. You could look at all the videos, the other video, to see how the equation works. Now, if I want to find twin primes, that is a pair of prime numbers whose difference is 2, that is, the first prime, the second prime minus the first prime, their difference is 2. So 5 and 7 will be a pair of twin primes, since 7 minus 5 is 2. That is, the distance between the primes is 2 digits. We could do a simple math to arrive to that equation. Okay, so if we want to find twin primes, we just have to find an x which solves these two conditions. It's pretty straightforward. X is got to solve for this equation. X plus 2, that is the next x, which is 2 integers bigger, also has to satisfy this equation. Very simple formula. Now I want to combine these two equations in one simple equation. As it turns out, I cannot subtract the two equations. Let me go back. I could combine these two equations by adding them together or subtracting them together. If I subtract this from this, then 2 minus 2 equals to 0. If I add these two together, 2 plus 2 equals 0, and I have to combine this function. As it turns out, I cannot subtract the function, because the original equation does more than just tell you which numbers are primes. It tells you the number of factors that that given number breaks down to. So, as I explained earlier, if I put in x in the equation, if it returns 2, it means it's prime, because it's telling me that the factors of it is 1 in that number, which is the definition of prime. If it tells me something like 4, it pretty much tells me that the factors of that number has 4 factors. Like if I plug in 6, the factors of 6 is 1, 2, 3, and 6. It has 4 factors. So given that, there might actually be two consecutive numbers which have the same amount of factors. There might be like an x which has 4 factors, an x plus 2 which also has 4 factors, and if you subtract those two, you get 0. So subtracting the two equations, combining the two equations together by subtracting it, won't help much because it might solve for other uh, values other than prime numbers. As it turned out, adding them is a pretty safe bet. If I add the two equations together, I pretty much get this. The sum from 1 to infinity of cosine x plus cosine x plus 2 is equal to 4. That's because this sums to 2 for x prime. This sums to 2 for x prime plus 2. 2 plus 2 is 4. This works because if it's not a prime number, if it's not a prime number, then it's giving you the factors. The minimum factors that a non-prime number could have is 3. If it's 2, it's prime because it's 1 in itself. If it's anything else, it has to have at least 3 factors. I think it's probably like 4 and above, but it has to have at least 3. So 3 plus 3 is 6. There cannot be no combination of non-prime numbers that will give you 3. Actually, I think 1 and 2 will give you 3, but 1 is not a prime number. We're not dealing with 1. I have to check into that, but every other number won't work. So this is a valid equation. It'll only solve for prime numbers. So that's it. Adding those two equations together, I get to this. Simple, straightforward. I could actually optimize this equation a bit, reduce it a bit, by taking advantage of certain things that I know. Okay. I add from 1 to infinity because I wanted my original equation to do more than tell me which numbers are prime. I also wanted to tell me if the numbers are not prime, to tell me how many factors it has. At this point, I really don't care about any factors. This is just an equation to actually determine a pair of twin primes. So I could start by 2, ignoring the 1 value. Once I start by 2, I'm knocking out the 1 echo repeating from both equations. 1 and 1, I'm knocking out 2 numbers, so this gets reduced to 2. Also, I don't have to add to infinity. Remember that once n is bigger than x, because this will be less than 1, this will always be 0. And here, once n is bigger than x plus 2, since this will be less than 1, this will always be 0. So the minimum range that I could have here is x plus 2. I can be certain that once n is bigger than x plus 2, this plus this will be 0, and I'm just going to get a whole bunch of 0 all the time. So there's no need to check this. Once n is greater than 2, this will never be true. So I could just check between. I just need to sum between 2 and x plus 2. So this is pretty much a reduced, a little bit simplified version of this. They both do the same thing. I could have just put 2 here and kept the infinity. It doesn't matter. Like I said, you could go to infinity to just make it a nice infinite function. But there's no need. Once n is greater than x plus 2, I'm just going to get a whole bunch of 0. So this bottom equation, it's a function that'll tell you which numbers are twin primes. If whatever x you plug in that this solves to, then you know that x and x plus 2, that is the next x is two digits away is true, and by definition, that makes it a twin prime. It'll solve for 5, 7. It'll solve for any pair of primes that are two digits away, two numbers away. So that's it. Very simple equation to determine twin prime numbers down here. Now I'm gonna I might show you later on, or if not, you could just play with the function in the equation yourself. How you could extend this in general to solve for any pair of prime numbers. You could find sexy primes. You could find in general any prime of any given distance between each other. It's gonna look very similar to this. It's just gonna have a little extra equation at the end. But let's stick with the simple example. So I showed you just by simply manipulating the original prime function equation that you could derive another equation like twin primes. Go ahead, play with this, test it out. You will see that this equation will only solve for twin primes. Thank you, and I will try to put other videos relating to computer algorithms and to other type of mathematical equations later on.